Good morning. I am out of the building, obviously, today, helping to adopt new curriculum, but I think that this might be more helpful just to make sure that you have something to review. I'll put this on my website as well as we go through some of this lesson today. Most of it's going to be directed by you, but I think for the homework problem in particular that I asked you to do last class, this might be helpful to start seeing it in a different way because I tried to make it color-coded on here. So for the first, 5 to 7, 10 minutes of class, I want you to please take out your reflection journal. If you don't have a reflection journal with you, please grab the notes from someone else and write it in your notebook. There's also some extra reflection journals by the snapshot of the day, the orange tape that's on the whiteboard. Right on the counter there should be a rubber banded set of reflection journals. So please grab one of those and spend about 5 to 10 minutes. I really want you to reflect on some of the ideas that we've talked about in class. So this reflection is incredibly important. Please pause the video until students have had a chance to do that. So we've talked about this limit definition of the derivative that you see right here, and I asked you to calculate the limit, use the limit definition to calculate the slope of this function at x equals 0. Now that's quite a big task to ask you to do because this is actually quite a challenging system to find a derivative for, but I think it's completely doable. And the first thing that I'm going to do is I'm going to do the algebra portion. So if I know that f of x is negative x squared plus 9, I'm going to do all of this stuff that's right here in blue. So if I have f of a plus h, all I'm doing is replacing whatever I see x with a plus h. So I see negative x, so I'm going to write down here negative a plus h squared. Oh, I forgot an x there. Sorry about that. And that's coming directly from this up here, so that 9x should have been 9x before. Plus 9 times, well, the stuff that's inside of this. So 9 times a plus h. A plus h. Now, all I'm going to do in this section is just algebra. So I'm just going to spend some time doing the algebra of simplifying this as much as I can so that I don't have to worry about it in the future. And I'm told that the point of interest, the a point, is 1. So the first thing I'm going to do is replace the a with 1 because that's my point of interest. So f of 1 plus h is the same as negative 1 plus h quantity squared plus 9 times 1 plus h. All I've done is substitute 1 for a. And I'm going to do a lot of algebra here. So this is the same thing as saying, oh, that negative sign comes down, and I've got 1 plus h times 1 plus h plus 9 plus 9h. All I've done there is I've distributed that 9 to both of those. So I've got, this is the same as negative 1 plus 2h plus h squared. I just multiplied this portion out, and notice the negative comes down right there. I've multiplied those two binomials to get this thing, and I'm just going to copy the rest of it down. So plus 9h. And then I'm going to distribute this negative to everything. I don't want to do that. I'm going to distribute this negative to everything and simplify. Sorry about that. So negative 1 minus 2h minus h squared plus 9 plus 9h. And last but not least, all I'm doing is algebra at this point, combining like terms. I've got negative h squared. That's my only squared term. I've got 9h and negative 2h. So that ends up being 7h plus 7h. And then the 9 and the negative 1 make negative 8. So I'll put negative 8 in there. Okay? So that's just this blue stuff right here. Just the blue stuff. All I've done so far is just this blue stuff. And I'm going to do it again with a different color, hopefully. I'll do it in red for this stuff right here. So f of a, well, if f of x, so if f of x is negative x squared plus 9 times x, all I'm going to do is do f of a, which our a was 1. Right, our a was 1, the value of interest is 1, so negative 1 squared plus 9 times 1, that ends up being negative 1 plus 9, which is 8. Oh, hey, that's going to be helpful for us in just a few minutes. So I've done all of the side algebra work. All I have to do at this point is plug both the blue stuff, the a plus h stuff from down here, and the f of a stuff from down here into this formula, which is our limit definition of a derivative. And I've posted the limit definition of a derivative in the class so that you have access to it. So here we go. I'm going to try and color coordinate as best I can. So this limit up here is equivalent to the limit as h approaches 0 of the blue stuff, the f of a plus h stuff, and in this case it was negative h squared plus 7h minus 8, minus, it's this minus sign right here. This minus comes down, I'm going to do the stuff in black, minus all of the f of a stuff. Well, what was the f of a stuff? The f of a stuff was 8. That 8 came from right here, and we dragged it into there. And then a plus h minus a all stays the same. All stays the same. Sorry, I should have done that in black. All of that stays the same, and it's a plus h minus a. Well, this is kind of redundant because like a and minus a always cancel out, so our denominator is really always going to be just h. So we're going to copy it down and simplify a little bit. H approaches 0. Well, when I look in here, I see a oh no. This is going to screw us up. Did you notice that I made a mistake right here? Negative 1 plus 9. Negative 1 plus 9 is not negative 8. It should be positive 8, which means that this right here is also positive 8 right here. So that should be a positive because that was a positive. That was a mistake I made earlier. So 8 and negative 8, those actually cancel out. I'm going to show that canceling here. That and that cancel out. And what am I left with? I'm left with the limit as negative h squared plus 7h over h. And it's the limit as h approaches 0. And gosh, I want to do this in a way that makes sense to me. H approaches 0. I know that both of these, have h in them, so I can just do negative h squared over h plus 7h over h. Okay, those cancel out, those h's cancel out. One of the h's on top cancels out with the h on the bottom. And I'm left with the limit as h approaches 0 of negative h plus 7. So this whole thing, all of this mess up here, all of this mess and all of this work simplifies down to just this. And that's beautiful because as h gets closer and closer and closer to 0, this term gets closer and closer and closer to 0. As h gets closer and closer to 0, if I evaluate this limit like we did in the first unit of this class, if we evaluate this limit is 7. And so the answer to this entire problem, the limit, the slope of the function, calculate the slope of this at 1, the slope is 7. The instantaneous rate of change is 7. This is a big, messy, hairy problem, but that's what calculus turns into. Although I think it should be recognized that all of this is algebra, all of this is algebra, and all of this is also algebra. The only calculus is this part, understanding what this means, that's the calculus part. And all the way down here, this last step was the only other piece of calculus that we did in this class. So I just want you to recognize that this is an algebra problem, essentially, with a hint, a flavor of calculus. Okay, we're going to move on. If you didn't get this down or write it down as we were going, I strongly recommend that you quickly take a picture, or you can review this this slide. I'm going to post this to my YouTube channel and on my website for a calculus class. All right, so today what you're going to be learning mostly through an activity with our guest teacher today is you will learn how to, you'll learn the limit definition of a derivative, which most of you already kind of know. We've already talked about it. We're going to find some context meaning to the sign, particularly around speed and rates of change and velocity. But more importantly, understanding what positive slope means, what zero slope means, and what negative slope means in the context of a real-world situation. We're going to understand a wide variety of notation, so ways of writing, and maybe we won't get to that today, but by the time we're done with this particular lesson, which might span a couple days, you'll understand how to write it differently and how to understand derivative or instantaneous velocity and why it's the slope of the tangent line. So that's something that you should be able to do. Really, I ultimately think that by the end of class today, you will understand this really, really well, and that you know that the sign of a function tells you something about the slope. The sign of the derivative tells you about the slope. We're going to do a POGIL activity today. That's really just an easy way for you to continue learning. Be really focused. You're not going to get very far in it, and that's okay, but your core understanding is the most important part. All right, so at this time, I'm going to have our guest teacher pass out some of the POGILs. It's called Derivatives 2. You are smarter together than you are individually. I do want you working with other people and checking your work as you go. I have given our guest teacher access to what I have done as I've gone through this problem, but I really want students to be doing this on their own. This should be a group activity and not a teacher-directed activity. I think that's really important that you are processing. You know a lot of the stuff that's in this POGIL too, so this should be a student-directed activity, and this will take up a lot of time. There's about the last 10 minutes of class. The last 10 minutes of class, I'm going to have you play the last part of this video in order for us to understand and consolidate some of our ideas, particularly around one of the example problems in this activity. So go ahead and pause the video. Most of the rest of class will be dedicated. The goal is to get through number 7, although take it slow, take it easy, and there will be a few notes about the last 10 minutes of class. Okay, I really want to focus here on the POGIL problem number 5. POGIL number 5 is one of those that's kind of characteristic. We've actually done a similar problem where our function was x squared. And remember, when we're finding the slope of a derivative at a specific point, I'm going to just kind of sketch out what this will look like. This curve is my x squared curve, and we're computing the instantaneous velocity when x is 2. So when x is 2, is at that point, we're calculating the slope of this tangent line. And that might be really clear to some of you. So this tangent line has a slope of something, but we are not entirely sure what that is until we use this limit definition of the derivative. So we're going to compute the f prime of 2. Remember, f prime is the slope of the tangent line at the point 2. So the slope of this line at 2 is what f prime of 2 means. Pretty straightforward. We're going to use the formula, the limit definition of the formula. So the limit as h approaches 0 of f of 2 plus h, because our point of interest is 2, minus f of 2 all over a plus h minus h. And remember, we can start not having to write the a plus h minus a, because it's always just going to be over h. So this is equivalent to, as h approaches 0, f of stuff squared, so it's 2 squared, stuff squared, so it's 2 plus h squared, so 2 plus h, all of that squared, minus 2 squared, all of that over h. So all I've done is plug 2 plus h into x squared, and then 2 into x squared. And we're going to just use some algebra to simplify. So this is the limit as h approaches 0. Well, 2 squared plus 2h. Excuse me, that's wrong. So 2 times 2 is 4, plus 2h plus 2h plus h squared. I've just expanded that into a binomial, because this is really just kind of as an aside, this is really 2 plus h times 2 plus h. And when I did that out, it got us here. And then we'll just go back to the original problem, minus the 2 squared, so minus 2 squared is 4, all of that over h, and then keep going. I found some like terms in here, so 4 and negative 4, those cancel out. 2h and 2h make 4h, so we're going to simplify, so 4h plus h squared over h. Limit as h approaches 0. Got to include that every time. This is the same as the limit as h approaches 0 of 4h over h plus h squared over h. I'm going to do some canceling h, and one of the h's on top. So I'm left with this limit, which is a lot simpler to do once I've canceled things out. H approaches 0 of 4 plus h. And the nice thing is h gets closer and closer and closer to 0. This h gets closer and closer to 0. So this equals 4. So the slope of this line is 4. It has a rise over run of 4 over 1. The slope of the tangent line at the point 2 is 1. Now, let's think about it for a second. We've spent a lot of time thinking about 4. We spent a lot of time thinking about this thing called h squared. This h squared function. Last class, a few classes ago, we did it when f was 3. We made a big table of values and said, oh, at 3 it's going to be slightly different. And if we don't have a tool in calculus to do this, we would have to do all of this all over again. And I really don't want to do this all over again. So I'm going to propose an alternative. Instead of plugging in 2 here, because every time that 2 is going to change, what if I did this problem when that 2 wasn't there and it was some other thing that I could replace later? So I'm going to change the slide real quick, because if I want to generalize, make a general statement about this whole process, we can generalize the process so we don't have to repeat the whole thing for x squared every time the value of a changes. So let's do that really quickly, and it's going to be a little bit more than you bargained for, but I think we can do it. So if I'm finding f prime of some value a that I'm going to choose at a later time, and I do the limit as h approaches 0 of f of a plus h. So that's going to be f of, it's going to be, well, f of x is x squared, so it's going to be a plus h squared. So a plus h, all of that squared, minus f of a, so a squared, some value, maybe it's 2, maybe it's 3, over h, because we decided that those are always going to cancel out. It's always going to be over h. Okay, when I simplify this, it's the limit as h approaches 0. The things I'm changing I'm going to do in red. So a plus h times a plus h, and then I'm just going to leave it minus a squared all over h. All of that stayed the same. The only thing that changed was the red. And that's the same as the limit as h approaches 0. A times a is a squared. A times h is ah, so plus ah. H times a is also a times h. And then h times h is h squared. And then we have to remember to subtract this minus a squared. Minus a squared all over h. Sorry about the flub up there. Erase that really quickly, make it look nice. So far we've done this whole problem, and all we've done is, I promised you that I would do the new stuff in red. So this is the new stuff, and all I've done was expand out my function over here. I've expanded that out. So, but I can see at this point that I've got an h squared and an a squared and an a squared. I'm going to cancel those out. So we'll clean it up just a little bit. So the limit as h approaches 0 of ah plus that's 2 ah's plus h squared over h. So the 2 came from ah plus ah, and that makes 2 of the ah's. Okay, and then a little bit more algebra. I see that both of these terms, this one has an h and this one has an h, so I'm going to split them. I'm going to split it up, which is going to make my life a lot easier. The limit as h approaches 0 of 2ah over h plus h squared over h. And then simplify this fraction. So h and h are on the top and the bottom. One of the top h's cancels out with the bottom h, so I'm left with just h. And almost last, this is all so far just algebra. So 2a plus h. Now when h approaches 0, this first term here it's not impacted by h at all anymore. As h gets closer and closer and closer to 0, this term just stays the same. And this term approaches 0. So equals 2a. So, whoa, this is big. Anytime I have a function on this curve, this x squared curve, if my point of interest is 1, my slope of that tangent line is going to be 2 times 1. Ooh, that makes sense. So I'll do it with the red line. The slope of the tangent line at 1 has a slope of 1. The slope, the m equals 1 for that red line. If the slope of the tangent line is, let's say, 2, which we did in the last problem, I'm going to draw that. It's 2. The slope of this green line is 2 times 2, so 4. Oh, that was the exact same thing we got before. If my input is, let's say, -2, negative 2. Oh, I know, I can see that, hey, my slope of my tangent line, that's the worst tangent line I've drawn in a long time. The slope of my tangent line is going to have a negative slope. The slope of this line is going to be 2 times 2 times 2 of, oops, sorry, 2 times the negative 2. So the slope is going to be negative 4. The slope of that negative line. So this speeds things up for us tremendously. So now, in this class, I'll make it a rule. Anytime we see x squared, you can use this 2 times the input to find the slope of that line. Anytime. It's a rule now. We've shown it generically, so we can use it always. All right, thanks for a great class. I know that this is a lot of new information. Please make sure that you finish through number 7 on your POGIL activity. And I hope to see you again on Thursday. Sorry about not being here today. I hope today was productive. Please email me if you have any questions. I'll leave my email at the top of this paper, rgermani@fwps.org. Or if you need to get a hold of me or want to watch this video again, it's at mr.germanis.org. So please check it out. I'll watch for how many video hits it gets, and hopefully it gets more than just the one that the teacher played in the class. So have a great evening. I'll see you next class.